So here we're going to just talk a little bit more about the periodic table in general, um, how it's structured, how it's organized, and sort of some of the other basic information we can get from it. So a lot of the credit for the periodic table goes to Dmitry Mendeleev, who proposed his version of the periodic table, which, as I'll show it here in a minute, we'll see won't look anything like what we're used to at this point. So this is what he, you know, came up with in around 1870. Now, Mendeleev was not the first one or the only one to try and come up with a method of organizing the elements. But he ends up getting a lot of the credit because um, his organization made sense in a lot of ways. And you can also see that there's some spots on his periodic table where he has these masses in here but no element name. And that's because he was predicting, based on the way he had organized things, elements that would eventually fill in those spots. And for the most part, a lot of the elements that he predicted would show up eventually were eventually discovered. Now, we're a long ways from what he saw then to what we have today with, now 118 elements. At that time, there were significantly fewer elements known, and because the idea of subatomic particles were not known, uh, it created some issues. It was commonly thought that we probably wanted to organize the periodic table on the basis of mass, but we have some issues. Tellurium and iodine here. Tellurium is first, but it's heavier than iodine. We have another example down here with thorium and protactinium. And we can see another example with cobalt and nickel. And so in the 1800s, it wasn't real clear why this was happening. It wouldn't be until around 1910, a little bit after, that we'd finally start to get an explanation for this. And here we, bring in a scientist who most people have probably never heard of, Henry Moseley. And so Henry Moseley, was the one who came up with the idea that we should, in fact, organize the periodic table on the basis of atomic number, or the number of protons. We don't necessarily hear a lot about Moseley because, unfortunately, World War I broke out and Moseley decided to leave his scientific career behind to go serve in the British Army, and he was shot during a battle at just 27 years old. But he was the first one to come up with this idea to group things on the basis of atomic number. So if we look at our periodic table again, we can see we have, and I'm using this one as an example because you can see it has some things based in different colors. Um, we refer to these two groups here, groups 1 and 2, you can see the numbers up at the top, along with groups 13 to 18, we call our main group elements. The elements in the middle, that's this 3 over to 12. You can see from this yellow color, these are known as the transition metals. And then we have these other two groups of elements down at the bottom, the lanthanides or rare earths, and then below that are the actinides. Um, This is the traditional way that we draw the periodic table, although there is certainly a strong case to be made that instead of drawing it in that way, we should draw the periodic table with those other elements in line like this. But we're not going to use this version because that's not the common form of the periodic table. But you can see some of the other um, classifications. We have column 1 are known as the alkali metals, but it's important to note that hydrogen here doesn't really have a good place to go. Hydrogen has a lot of properties in common with that don't really let it fit in very well. We put it in that column traditionally because it has, we'll talk about what this means much later on, but it has what we would call one valence electron. But it doesn't really have the same chemical properties in most cases as the alkali metals. Group 2 are the alkaline earths. Over here in group 17, we have our halogens, and then group 18 are the noble gases. So the metals, which are all on this side of the periodic table, are almost all solid. The only element that's not a solid at room temperature is mercury, and most of them are very good conductors. Over here, we have our nonmetals. Most of them are gases, and they're very poor conductors. In between that group, boron, silicon, germanium, arsenic, and so on, those are known as the semimetals or metalloids, and those are most commonly known as semiconductors or often used in computer chips. The other thing to point out, and I'm going to bring up a clean copy of this periodic table so we can do this. No, not that one. Most elements, all of our elements have either one or two letter symbols. And in most cases, those symbols are logical based on the name of the element. There are, however, a number of cases where the symbols are quite different from the element, such as sodium, potassium, iron, silver, gold. We could even add copper to this list because there's no U in copper. Tin, mercury, here's lead, antimony, tungsten, and I think we've got them all. The reason I highlight these elements is they all have sort of unusual symbols given their names. And that's because their chemical symbols come from the names of these elements in other languages. So sodium known as natrium, or potassium, which is known as kalium. And you can look up what these names stand for, or the abbreviations are for the rest of these elements if you're interested. But that's why we have about 10, 12 elements that have sort of unusual symbols given their name.